Yeah, hi guys. You're welcome to my channel. Today exercise we're going to learn about on delay timer and off delay timer, the logic of on delay timer and off delay timer. So I'm going to walk you through difference between these two different timers and when to use them, okay? Because oftentimes most people find it difficult to distinguish the two functions. So today I'll walk you through on how to use the two, when to use on delay and when to use off delay and their different logic application. Okay, now let's start with this logic here. I have with me here on delay timer. This is on delay timer. So the application of this is the logic. Now I want to put on this pump. Okay, the logic is that on delay timer is what I need to put on this pump because I want this pump to shut down at a given time. I want the pump to shut down after a specific time. When the duration elapses, when the transition time is completed, I want the pump to shut down. Okay, now in hardware component, if you source for on delay timer and you don't have it, rather if you source for off delay timer and you don't have access to off delay timer, you can now use on delay timer to put up a logic that will do the same function, not exactly but similar function. But on delay timer is to shut down while the power will still be on the timer. But off delay timer will shut down and shut down the entire circuit. I repeat again, there is a function called cooldown duration. Cooldown duration is a particular function we use to shut down a generator set. So if I put on a generator set and I want it to shut down by an hour, so what I will do, I will put up a logic that when I put on the genset, I will shut it down too, but the genset will not shut down until after 1 hour. Okay, so that logic, I will use off delay timer to put on the logic so that I will shut down the gen after 1 hour. And after that 1 hour, when the gen shut down, the entire circuit is going to close signal. The signal for the circuit is shut off. But on delay timer, when that recension time is complete, the equipment will shut down, but the power will still be maintained to on delay timer. That is different between on delay and off delay. When off delay is shut down, the logic completely will go off. The signal of the power will go off. But on delay timer will maintain the signal to the logic, but it will shut down the equipment, but the signal to the relay will still be on. So that is different between the two. But there are some trickish way that we use to detect the function of off delay timer by using a logic to represent that function. Like this logic now, we shut down this pump and also shut down the signal to the circuit. All right, so let's do the simulation now. This particular circuit will do almost exactly what off delay timer will do. Okay, so that is why I use this logic to represent the function of this, but both of them are not the same. Look at this circuit and this circuit, they are identical, but this one is off delay timer. Look at it, off delay, and this one is on delay timer. Now I will show you difference between these two logic now. Let's simulate this. Remember, the subject is that I want this pump to shut down after a time, a particular given time. Perhaps I want this one to shut down after 5 seconds. So when the 5 seconds elapse, this pump will shut down. Okay, let's do that now. All right, I want to put on this pump using this on delay timer. I put on the logic. The pump is on and the timer is on, right, is now counting the completion. It's now completed, so the system shut down. So this is way to represent a logic so that if you want to use off delay method and why using on delay timer, this is how to represent the logic. You now see that when I close here, the power go to my pump, and here will latch the pump because this is contactor and this is representing the pump. So when this one now latched and I have T1 here for my on delay here, and once this one shut the pump down, the entire system will also shut down because this pump is what I use to lash. And once the lash is no longer there, the timer itself will get disengaged. The power to the timer will be cut off. The power to the contactor will also be cut off. So what is returning the signal here is my lash. You now see that I feed my timer through the contact of the timer. I repeat, I feed the timer through the contact of the timer so that I want the entire system to shut down. If I want the timer to maintain power while shutting down this, I will change the logic. So I will feed this timer from another means, not coming from here. So because I want the system, I want the logic to shut down. That is why I feed the timer through the contact. All right, now let's do the same here. You will see that this one will fail. This one will not work exactly what I have here because this logic is wrong. This is not the logic for off delay timer. Off delay timer, we don't need to maintain power steady to the timer. We just need a pause. Once you need a time here, once you energize the relay, then the relay counting time will not start until you de-energize the relay. And the difference between the two, pay attention please. Once you energize this particular on delay timer, the contact will not change. The contact position, the state of the contact will remain the same. The state of the contact of this on delay will only change when the preset time of the timer elapses. That is when the contact will change state. While the off delay timer, immediately the timer is energized, immediately the signal comes to the coil of the timer, the contact will change state immediately. So the contact of this off delay change state 2 times. When the first time, when the timer is energized, the contact change state. That is the first time the contact change state. The second time that the contact will change state again is when after preset time of the timer, when the preset value is now elapsed. After counting the value inputted on it, the contact will make change again, go back to the original state. Now, this one is normally closed. Once I energize this coil, here will open. Now, once I de-energize the coil, the relay starts counting. When the time of counting is completed, the contact will change state the second time again. So transition time of this one is 2 times. It will change immediately when energized. It will also change when de-energized after counting completed. Okay. Now, if you misuse this one to this one and put up this logic, then you will see what the result will now implies. Let's put it on now. Now I want to put it on. I energize. Now it's on. I now lash my pump. My pump is working. Okay. But the timer is not counting because the power is still maintained to the coil. So it will start counting when the coil is de-energized. So let me de-energize the coil. I de-energize the coil through this. It's now counting. Look at it counting. Now the counting is of no use. It's now useless because the subject of the issue is already shut down. The subject is for the pump to shut down. Meanwhile, the pump has already shut down when I de-energize here. So counting is of useless, it's of no use. It's now the essence of this is now defeated. So you don't need this one when you want to put off this particular logic. If you need this logic, you know you don't need this. So you have to change the logic if you want to use off delay timer. Okay, so if you're expected to use this logic, this is the relay that you use off delay timer. You will not use that same logic for off delay. The logic of off delay is going to change, and this is the logic for off delay. I repeat again, the coil of off delay timer must be de-energized for the contact, for the subject of the appliance you want to control to be fulfilled. So before off delay timer we start counting, you must de-energize the coil. The coil shouldn't have a supply because it has internal storage of source power. It has like a capacitor embedded in it. So that capacitor will sustain the signal while the counter will count. But when the signal remains to the coil, the relay will not count until you de-energize the relay coil. So that is off delay timer. Okay, so this logic now will not work because this is logic for on delay timer. And this particular logic is when you want to use on delay as a function of off delay, that is when you put up this logic. You can see that, watch again, you can see that when I energize, the relay get energized and this one is counting. Okay, it now shut down. Once this one shut down, the logic shut down. And that is exactly what off delay does, but in another logic representation. All right, in a summary, whenever I want to use a function of cooling down duration, you want a particular plant or a particular equipment to shut down after a preset time. This is the logic you will put up. Then you now use on delay. But if you want to use off delay, which is actually the original design for duration monitoring, so in that case, you are going to use this logic, not this logic. Okay, so the logic for on delay and logic for off delay, they are not the same. They are two different logic. So you cannot make a replacement of these two timer in the same logic because their contact does not function exactly. This contact will change state immediately you energize this, but this contact will not change state when you energize this. This contact only change state when the preset time of the timer elapse. Now this contact will change state two times. The first time is when the coil is energized. Second time is when the counting time elapse. So that is the two times this one make change, the contact. So these two logic will not function where you use two different timer function. Now if you want to use off delay, look at the logic here. Let's simulate this, okay? I put it on. My pump is running. The off delay is counting. Look at it. It now shut down. The reason is this. Upon pressing here, I have a momentary switch here. This switch now, this my particular switch I have here, the auxiliary of this part, let me shut down the simulation. Now this is my start switch. This start switch, I have another additional contact that is going to be added to the back of this contact so that when this one closes, it's going to close together with this simultaneously, both of them. They're going to be a kind of this. Let me show you. They're going to be something like this. Yes. So whatever thing affect this will affect this. Once this one closes momentarily, this one will also close momentarily. So there's a dotted line crossing them. If I want to do that, just for more elementary, let me take it away. It's not ideal. So now this switch, there's a contact here. So the back of this contact is where you're going to install this. So once this one close momentarily, this one will also close momentarily. All right. So upon this one closing, power get to this, and also this one get closed immediately. This one will also get closed. So when power come to this, here will close. Like I told you, the contact of this coil changes state two times. The first time is when energized. When energized, here will close. So in that case, I'll have power here because here has closed that time. I'll have power here maintain, and this one will lash here and here. This one will lash this. So I'll have power here maintain. Now I don't have power here because here is momentarily. So upon completion of this counting, here will open to de-energize this. And once here open, this one will get de-energized and here will get de-energized. The entire logic will shut down. Okay, so this is the logic you will use. We want to use off delay timer. You will no longer use this. This one is for on delay timer. And this particular logic is the only way to use on delay timer in place of off delay timer. That means if I want the function of off delay timer, this is the logic I will use so that when the preset time elapses, the entire system will shut down. I don't want power still maintained here while this one is cut off. Okay, off delay timer, cool down duration is what I want to teach you how to design a circuit for off cool down duration. Cool down duration is something that will shut down on your behalf, shut down the plant on your behalf. I want the operator to shut down the plant perhaps after 1 hour. So operator can actually shut down the plant and close for the work for the day. You cannot now hold on. For example, let me give you another narrative. I want to pump water into a reserve tank, and that reserve tank is about 5,000 liters. So shutting down my plant will now devise the means of shutting down that pump. The pump will shut down, the pump will get filled up after 2 hours, for instance. I will put on the pump, but the pump will shut down after 2 hours. The tank will fill up after 2 hours. So I will not wait for the plant to pump till the reserve tank get filled up for 2 hours. So what I will do is that I will put on the pump and also shut down the pump and leave the premises. So the system will start to run. After 2 hours, the plant will shut down. So I cannot wait for 2 hours to shut down the plant. I want the plant to run for 2 hours and shut down. So in that case, I will put it on and immediately shut it down again and leave the plant. So because of that, the system will now start working. After 2 hours, the plant will shut down because the instruction is that shut down after 2 hours. And shutting down will also involve shutting down my circuit, shutting down my panel. Okay, shutting down that particular circuit that activated the pump. So this is the logic that is necessary for you to use. Okay, all right. So let me also relate this to your PLC program. I want us to write a program and also use this on delay and use this off delay, because most program you need to understand the function of the similarity between these two timers so that you know how to when to use them in your program and when to use this, know when to use this. So for my schematic, for my control, this is the circuit, this is the logic to use whenever I want to use off delay timer. Then when you want to use on delay timer in function of off delay, if you want to use on delay function to do the job of off delay timer, so this is the logic you use. Okay, and mind you, when you want to source for the hardware of off delay timer, is more expensive than on delay. This particular timer, if you want to purchase the hardware, you want the physical look of it, the physical component, is more expensive than this because this one has a capacitor that is sufficient in storage power embedded in it. Okay, so this one is more expensive in hardware for you to source for it. So but if you if you can't have it, if you can't have access to this, but you have on delay timer, so you now put up this logic to perform the function of this. Okay, all right, so you have learned that the logic of on delay and logic of off delay, they are not the same. So this is the logic for off delay and this is the logic for on delay. So we don't need this because this is not what we need. So that is the information I want you to I want you to understand, I want you to learn. So what I want you to do now is to share this information, share to someone that need it most if you don't need it, share to students, share to automation engineers, share to trainees. So you also have to subscribe to this channel, because if you don't subscribe, if I have similar information, Facebook is not going to send it across to you. The only way Facebook send this update in subsequent time to you is when you share and when you also like. That is indication for you to tell Facebook that this is of a higher relevance to me. If you don't subscribe and you don't share, Facebook will no longer bring the updated information coming from the channel. It's only when you like and share, that is when you now tell Facebook that I need this information. So Facebook will now send across to you whenever the updated information that's related to this is published. Okay, all right, thank you. So let's go to automation software and relate this again in our tier portal Siemens. Okay, all right, thank you.